So today I'm alone here and I want to talk about a very important topic. It's how do we scale your website? It's a very important topic and it has a lot of details inside. So I thought of getting an approach of, explaining things step by step, right? First of all, probably we are a headless CMS, which means that we host your content. Basically, we give you an editor where you kind of edit content, save it, publish it, and then an API that allows you to fetch this content and throw it on your website to whatever technology you have. Gatsby, Next, React, anything you want, Node, PHP, any technology you want. But this makes us very critical for your website. Basically, if our API goes down, your website goes down, and that is a problem. So we should do our best not to have our API going down and also to have our API scalable. So here I have to talk about different things. First of the things is that we are a mutualized platform. People call it SaaS. This is the most interesting thing about a SaaS platform is that all the clients will share infrastructure. Why is that interesting for you? Well, it's very simple. It allows you not to pay the whole cost of hosting all these things that you need to host to have your website available, basically our API, your content available in different regions around the world and, scalable. So if you have more requests, we still can do that for you. But you're not paying the full cost of the infrastructure because we share it with different clients. So if we have 100 clients, if we have 1,000 clients, if we have 1 million clients, the infrastructure cost that we are paying, well, everyone is paying it together. So that makes costs much lower. But that comes with problems, of course. Now, what happens if we have a lot of users, right? Then we have to add more servers, and then more users, more servers. And this is exactly why I'm doing this video, because we are having more and more users every single month, and we have to think about this seriously. So the first thing that we did in our infrastructure is that we separated the writing room from the API. Basically, if there are a lot of people editing in the writing room, basically saving things, publishing things, uploading images, it will never impact the API. They are two different services, two different servers. They are very separate. So that's a very important thing to do, not to kind of link these two systems together. The other thing that we did is, of course, having different servers serving our clients. So basically, you like different clients will land on different servers, but still some will land on the same server. It's pretty much like sharing infrastructure is like you have roads and cars, right? So if you have a car, well, you have different cars on the road. Well, if one car is going slowly, or like just doing some problems, then all the other cars will be slowed down. How can we solve that? We add more lanes. In Prismic, we add more servers, right? Simple. Now, even by adding more lanes, still, you can say lanes are processes or threads. You can relate to that. It's a metaphor. But still, if one car goes to the other lane, well, still you'll have problems, right? But you can't, in roads have different people, not each car having its own lane. That's very, very costly, right? You can't have as many roads as cars. But the good news that in IT and infrastructure, you can still do that. So this is what we're working on today. What we're doing today is that we are using containers. Basically, containers, you can imagine them as lightweight machines, okay? So what we're working on for our API is we want every client to be isolated from the other client. Basically, if you have a client that is doing big requests, huge requests, right? And they are using a lot of CPU, a lot of memory, all of these kind of things, they should not be able to impact any other client. Actually, no request should be impacting the other request. So even for the same client, if you have one huge request and another request, they should not be sharing the same CPU, the same memory, so that no one will be impacting the other. So it's as if each client is getting its own machine. Now, you might say, like, this is very, very expensive, right? Giving a machine to every request. But actually, it's not. With containers, they kind of lightweight machines on top of machines, actually, that's why they call them containers. You will be able to have that kind of isolation. And that's what we're working on now. But the good thing about it is that how many, you can ask me the question, like how many machines should we be spawning? Like 1,000 machines, 10,000 machines, how many of these? Well, it gets to be very, very dynamic, because when we have a lot of requests, we can spawn new containers, okay? Handle the requests. If we don't have requests at some time, well, we can remove some of the containers and things will go back to normal. So we only use the machines if we have requests that we need machines for them. So it's very dynamic. So that we have two properties we win from this. First, we can have isolation. No request can bother the other request. Everything is isolated. Every client is isolated from the other client, you know, and you get infinite scalability. Basically, anytime someone will tell me, like, we're having 2 times more users, 5 times more users, 10 times more users, it's only a good news, because we're ready for it. It happens automatically. There is no ops team. There's no one I have to call. The system is working, spawning new machines and handling your requests. I hope this will explain what we're doing. And I guess it will be hopefully soon, like in next month, we'll be deploying this.